Hello everyone, today 1st June 2024, it's exactly 2 years after publication of this paper titled Worldwide Statistical Correlation of 8 Years of Swarm Satellite Data with 5.5 plus Earthquakes, New hints about the pre-seismic phenomena from space. I would like to say thanks to the authors that cited this paper that received 27 citations, and on the website it recorded more than 3,200 views. So a special thanks to all of you that consider this paper when you have write other papers, and also to all the people that viewed this paper. But what was about this paper? Here you see the graphical abstract that represents the paper. In the website you can find also a video abstract with a short summary of the result of the paper. The paper concerned the analysis of the first 8 years of satellite data from European Space Agency's SWARM mission correlate with the occurrence of earthquakes of magnitude 5.5 or greater wherever in the world in the same time, so the first 8 years, that is almost from 2015 up to 2020. The method applied in this paper consists firstly in extracting all anomalous signal from swarm satellite magnetic and electron density signals. This job has been done only when the geomagnetic field is quiet, checking at the geomagnetic indexes. I would like to say that here geomagnetic quiet time is defined with a very strong criteria. So we don't only exclude geomagnetic storm like the big one occurred a few days ago, but also we exclude any minor activity that is not even classified as a geomagnetic storm. So we collect all the anomalies occurred in the equatorial and mid-latitude region, or better between -50 and +50 of geomagnetic latitude, and then we correlate with the earthquake occurrence. How we do this job? We select one earthquake for each time, and considering his origin in time, the origin time of the earthquake, and also the epicenter of the earthquake. We check the anomaly of swarm. If there is any anomaly, then we measure how much time the anomaly occurred before the earthquake and how much far, and we place a point in this graph that is a superposed epoch and space approach. Then we repeat this job for all the earthquake under the analysis. In this case, in all the paper, there are considered more than 2000 earthquakes, about 2200 earthquakes. And we then divide in bin for time and space this graph, and we measure the concentration of anomalies. And we represent the concentration with the color. Higher color represents higher concentration of anomaly. In the paper, we also divide the earthquake in 3 different categories. The magnitude, as you see here, smaller magnitude, intermediate, and higher magnitude. Higher magnitude means greater than 7.5. We divide for focal mechanism, and we divide for earthquake whose epicenter was in the sea or in the land. And the analysis can be then searched if there is any difference in these categories. We confirmed a result of the previous paper we published in Scientific Report, and the first author was the scientist. You can find in QR code to download that we already identified that at higher magnitude the anticipation time is longer. This is not a new result because Vitaly in 1987 already published a paper that proposed this dependence as empirical law called the Vitaly law. But in the paper of 2019 scientific paper was the first time this law was applied to satellite data. But what was interesting is that in that paper we analyzed the 500 days before the earthquake. Here, considering a more longer data set, we were able to extend to 1000 days before the earthquake. And we saw in the previous paper this exactly dependence, but we don't see the concentration for the magnitude 7.5 plus earthquake. In this paper we were able not only to identify this concentration, but this concentration is exactly where the previous paper pointed but was not able to found because the investigate time was too short. So this is a confirmation of the previous result, make it stronger. So it says that if an earthquake is in preparation, if it will be bigger, we need to see more time in advance the anomaly, even from space, and this time could be so much long, more even years before. But this is not strange because the preparation phase of earthquake is a very long process. An earthquake on the fault could take years or even 1,000 or 10,000 years to prepare to the time of recharge of the single fault. These times normally are very long, but depends fault by fault. So it's not surprising that this time is so long, and overall this time is much higher as the earthquake is also higher magnitude. Then what we found in this paper, what we introduce also of new in this paper, is the investigation of the frequency of the magnetic signal. So we divide the analysis in three frequency bands: the signal that are faster with a period from 2 to 10 seconds, an intermediate period band from 10 seconds to 25 seconds, and a slower signal from 25 to 50 seconds. So it is possible to say that it seems the earthquake starts with a slower frequency magnetic signal, and as the earthquake is approaching, the frequency increases toward the earthquake. This result needs further investigation and is still under investigation. But if we divide the group of these earthquakes with the earthquakes that are in the highest concentration, we found an interesting point, that this frequency seems to be linked, as you see from the picture of the graphical abstract, to the location of the signal. So it seems that from sea earthquake, the signal is higher frequency, while from land the magnetic signal that preceded the earthquake occurrence presents lower frequency, so higher period signal. And this means signal more in the band of 25-50 seconds, for the sea more signal in the band of 2 to 10 seconds of periods. And this seems to be statistically significant result. Finally, you can see in the appendix that we check if the particular decluster algorithm or even the decluster itself altered the result, as was suggested by one of the reviewer. And this was very great suggestion, I would like to say, and I would like also to thank all the reviewer that permitted to improve a lot this manuscript. So as you see, in the four situation, we applied the main result of the paper is made with Reisenberg decluster, but we also try to apply another methods, and the results are very similar to the one in the paper. But also we tried another approach, to use the original catalog without the cluster it. The decluster means that normally a main shock, a biggest earthquake, is preceded by foreshock sometimes, and almost always is followed by aftershock, the aftershock sequence. So decluster the catalog means remove all the smaller earthquakes that brings to the main shock and the following earthquakes that are the aftershock sequences. This is important point when we do a superposed epoch approach, because if we have one anomaly, then we superpose for any earthquake, so we count more time. If we don't remove the foreshock and aftershock, then we count more time the same anomaly, and we could obtain artifacts that are due just for the seismic sequence. But it's important also on the other point that we don't obtain aftershock in function of the decluster algorithm. So we present one of the results of the paper without the cluster decalog. And finally we also present the result considering the higher magnitude, and so without count more time the anomaly with the earthquake, considering the full catalog without the cluster, but associated with the highest magnitude, that in some way it's a way to be safe if the decluster of the catalog was not done, as in this case, but also we don't count more time because we associate only with the highest magnitude event when the same anomaly is compatible with more earthquakes, because generally one earthquake can produce not more, like one anomaly, or better, it can produce more anomalies, but the same anomaly cannot be produced by two or more earthquakes. It could happen that there are two anomalies and the satellite pass at the same time is not able to distinguish the two anomalies, but this is a very unlikely case, but even it is still a possibility. So as you see, what is very interesting from this final comparison is that the results are strong against the different approach that is used. Some concentration, especially 80 days before the earthquake and 20 days before the earthquake, remain with a different weight, but in all the investigation. So that means that the cluster sure play a role, but is not crucial. In conclusion, we can say that this paper confirms the existence of ionospheric seismo-induced signals before the earthquakes. We are not able yet to make a link one by one between an anomaly and the earthquake, but statistically, before about 18% of the magnitude 5.5 plus earthquake worldwide, there is some increase of concentration of anomalies from ionosphere that are statistically significant with respect to an homogeneous distribution in the space and time of the same number of anomalies. So we found more anomalies than what we would expect without earthquake events, proving that they are statistically linked to the earthquakes. We also identified some dependence with the location in sea and land, and also a dependence with the frequency of the magnetic signal that could bring to the next stage of research in earthquake precursors. I thank you so much again for the interest for this paper, and invite to read, if you not yet read, on the website of the paper with the QR code or the link in the description. Also, if you want to follow my research activity, please subscribe to the channel, and you can put a like to the video, it's greatly appreciated. I wish you an absolutely wonderful day. See you, bye bye.